So we started yesterday by talking about some probabilities of event. We talked about OR probabilities, the probability of drawing a queen or a 5, and then we would add those if it was an OR, and then we'd subtract off the probability that something was overlapping. That's what we did yesterday. Today we're talking about the probability of independent and dependent events. This is supposed to have a time sign between it. Yours does on your paper, don't it? Okay. So, two events are independent if typing, the occurrence of one has no effect on the outcome of another. So if they have no effect on each other, then they are independent events. So that means I'm going to flip 2 quarters. Okay? Does me flipping 1 quarter have any effect on me flipping the other quarter? Whether it lands on heads or tails. Not unless they bang into each other. Right? Okay. So those would be independent events. Okay? That would be like two totally random things. What's the probability of a freshman and a senior getting chosen to go to some field trip? You know what I'm saying? So they have nothing to do with each other. So when it's an and probability, we're going to multiply. So yesterday we did or meant to add, and means to multiply. So you might want to write that on your notes somewhere because it's not on there. And means multiply. So if it said or we add and we multiply. Or we add and we multiply. Remember, probability is out of a total. So the first few things, just practicing with decimals. It says the probability of event A is 0.3 and the probability of event B is 0.42. What is the probability of A and B? So what are we supposed to do to find the probability of both of them? Multiply. So that's all we'll do. So y'all help me out. We're going to say 0.3 times 0.42. My calculator did something weird. 0.3 times 0.42. Yeah, don't round it. Just tell me what it is. 0.126. Did everybody get that? Okay. So y'all do the next one. How do you find the probability of A and B? You multiply them. 0.8 times 0.27. And what'd y'all get? 0.216. Any questions about that? Well, look at number 3. It's slightly different. How is number 3 different? Right. So they give you the probability of A, and they give you the probability of A and B, and ask you to find the probability of just B. How do you think you do that? You do the opposite. If A times B equals A and B, then to get just one of them, you would take the A and B and divide by the one you got. Right? So we're going to take 0.3 and divide it by 0.6. I don't think so. 0.3 divided by 0.6. You did it backwards. 0.5. Okay? So if they give you A and B, you divide that by the one they gave you to find the other one. Does that make sense? So same thing on number 4, except this time they gave you B and A and B, and you got to find the probability of A. So how do we do that? Right, we do 0.225 divided by 0.25. I trust you. My fingers are just not working. Get 0.9? Any questions? All right. So there's how you do the math. Now let's do it in some word problems. And they're right there typed out for you on your notes. And I'm saying in advance, it's very possible there is a typo or 3 or 4 because my program that I use does not do spell check. So it's all up to my lovely spelling, and I probably mess up. It says, for a fundraiser, a class sells 150 raffle tickets for a gift certificate and 200 raffle tickets for a booklet of movie passes. You buy 5 raffle tickets for each prize. That's supposed to be prize. See, there's one right there. Fix that C to a Z. What is the probability that you win both prizes? Okay. So we want the probability. There's 150 raffle tickets sold for the gift certificate and 200 for movie passes. What's the probability that we win both of them? So these are independent of each other, right? Whatever my probability of winning the gift certificate has nothing to do with my probability of winning the movie passes. So how many, what's the favorable outcomes of me winning a movie ticket? 5 out of how many? I said it backwards. For the gift certificate, it's 5 out of 150, right? And for movie tickets, it's 5 out of 200. Y'all agree? Y'all agree? So you're going to multiply them, because I'm both. That's an and. So it's going to be 25 over, what's 50? 150 times 200. 30,000? It's 30,000. See if our calculator will reduce that. And hit math, enter. It will, won't it? Where'd y'all get? Did your calculator tell you 1 out of 1,200? Yes. Now hit math, enter. It won't do it. Your calculator's too big. But that reduces to 1 out of 1,200. So if our calculator won't reduce it, we know by ourselves that this would be divisible by 5, don't we? Right? I don't know what 30,000 divided by 5 is. If you can do that, you get 5 out of 6,000. And maybe your calculator will reduce 5 out of 6,000. Try that. Will your calculator reduce 5 out of 6,000? Math, enter. What the heck was up with these calculators? Maybe they're just too old. All right. But anyway, you can divide it by 5 and get 5 out of 6,000, then you could reduce again. Okay? Goodness. Okay, let's talk about flipping coins. I want everybody. I'm going to give you pennies. If you got something else, you'd rather use a quarter, you can use a quarter. Now we're going to do it on a piece of paper or a book or something, so it's quieter. So if you do it on your book, it'll be a little bit quieter. And I want you to flip it 20 times, and I want you to keep a tally of every time you hit heads. You land on heads. Okay? So 20 times, exactly 20 times, and I want you to keep a tally of how many times you land on heads. Okay? Ready to go. Here. You don't have to flip it all the way to Jesus. Start over. Yeah, it makes our hands stink, don't it? Money is so dirty. Ouch. All right, y'all keep going until you get to 20. Oh, are you going to start up? All right, y'all got how many heads you got? Everybody done 20 times? Sounds good. Dylan, how many times did you get head? 9 out of 20. Veronica, how many times did you get head? Oh, look at here. Dalton, what about you? 8. Aww. Hannah? Perfect. This way?
1.
Jared?
8.
Look at that.
I got 20.
Now, okay, if I flip my quarter one time, what's the probability I land on head? 50%, a half, right? All of y'all got close to a half, didn't you? This is called an experimental probability because we actually performed the experiment to see how many times we land on heads, right? That's what that's called. Experimental probability is when you actually do the action. You actually take a poll. You actually do whatever. You're not just guessing something or knowing what it's supposed to be. We tested it out, and we got pretty close to a half, right? Hannah got exactly a half. Josue's went over. Y'all are all 1 or 2 under, right? So y'all did good. Good job. So we're going to work some problems now. But anyway, I just wanted y'all to do that because it was fun. Change your pace, right? Yeah. What'd y'all do in math class today? We flipped coins. If you got one of my pennies, you can keep it. Merry Christmas. I paid y'all to come to class today. There you go. Y'all can tell the ones that weren't here today, Miss Isbell paid us to come to class today. There you go. All right. So here we go. Here we're flipping 2 quarters or flipping the same quarter twice. What's the probability of flipping a quarter twice and landing on heads both times? Well, what's the probability that it lands on heads one time? 1/2, right? What's the probability that lands on heads again? 1/2 again, right? So the probability that I get 2 heads in a row is 1 out of 4. Multiply across the top, multiply across the denominator. So, okay. So if I did it like this, what's the probability of landing on heads? The probabilities will get smaller as we go. Does that make sense? Okay, what if I say we flip the quarters or flip whatever coins we have 200 times instead of 20 times? It's going to be even closer to half, right? It's going to get even closer to that probability that it's supposed to be. Like the more times, if I had just done it 3 times, well, let's say 6 because that's an even number. If I'd only done it 6 and I got heads 5 times, 5 out of 6, that's kind of a skewed probability, right? That's kind of skewed. That's why I said 20. If we had done 50 times, it should be even closer to a half. If we did 100 times, even closer. 200, even closer. Does that make sense? So the more times something happens, the more times we experiment with something, the more it should get closer to what it's actually supposed to be. You know what I'm saying? The probability is supposed to be a half, but if I just flipped it one time and I got my heads, I'm 2 out of 2. Well, that's saying that I'm going to get heads every time. Am I going to get heads every time? No. So that's why when we do experiments, the more numbers you have, the closer it's going to be to actuality. Does that make sense? All right. So I'll quit rambling about that. Let's talk about dependent events. So flip to the back of your notes, please. So we got a few different scenarios I'm going to cover for the rest of the class. It's when the outcome of one event does affect the other. Okay, so if dependent events is one outcome does affect the outcome of another. So that would be like me drawing something out of a box of different colored marbles and I keep it out. Well, that's going to affect the outcome of pulling out the next thing because the total is going to change, right? Right? So it's when something does affect something else. So here we go with a bag of marbles. A bag has 4 green marbles, 1 blue marble, and 2 red marbles. Find the probability that you draw a blue marble, you replace it, and then you draw a green. So what does that mean, I replace it? I reach in my bag. I got an imaginary bag of marbles here. I reach in, I draw a blue, and then what I do with that blue? Put it back in the bag. So does my total change when I go to get a green? If I put the blue marble back in the bag, does the total change when I go to get a green one? No. The total is going to be the same. So what's the probability that the first one I draw out is a blue? How many are blue in the bag? 1 out of how many total? Anytime you're doing probabilities, you need to know a total. So we have how many total? If I can spell total. We have 7 total marbles in the bag. Y'all agree? So the probability that I reach in and I grab a blue one first thing is 1 out of 7. Does everybody agree with that? Okay. Then I'm going to put that back in. So when I go to get a green one, is my total going to change? No, it's going to stay 7. Does that make sense? And then I'm going to reach in and draw a green. Now, assuming that all these marbles are the same size, is my effect of drawing a blue going to affect my green one, whether or not I get a green one? No, it's not. These are independent, okay? So if I put it back to where I started with, it's independent. So how many of them in there are green? 4. So my probability that I reach in and get a blue, put it back, and then pull out a green is going to be 4 over 49. Multiply across the top, multiply across the bottom. Okay, those are independent events. One does not affect the other. However, on number 2, it says I'm going to draw a blue and then a green without replacement. That means I reach in, I draw a blue marble, I keep it out, and then I go back and get a green marble. Okay? So what's going to happen to the total when I go for the second time? It's going to go down by 1. Right? All right, so here I am. What's my probability? Okay, all my marbles are in the bag. What's the probability the first one I draw is blue? 1 out of 7. Same numbers I just used, just a different situation. All right, so now I pulled out a blue and I kept it out. How many total marbles are in my bag? 6. So my total goes down by 1. If I don't replace it, the total goes down by 1. But the first one I drew was blue. So how many of them in my bag are green? That hasn't changed, has it? So it's still 4. So if I keep it out, my probability of getting a blue, keeping that one out, and going back for a green is 4 out of 42. Now, which one's smaller? 4 out of 49 or 4 out of 42? Actually, 4 out of 42 is a higher probability. Right? Right? It's got a bigger denominator. Or smaller denominator, sorry. All right. Here's another one about a box of pens. Ink pens. All right. A box has 3 black pens and 5 blue pens. You take one out. You take one at a time and do not replace them. Find the probabilities. So I said I do not replace ever. So the first one wants me to reach in and get a blue, keep it out, and then reach in and get another blue. All right. So first, if I'm doing probabilities, I have to know the what? Total. How many total pens in the bag or box or whatever these are? 8. 8 total. Okay. So what's the probability that the first one I get is blue? How many are blue? 5 out of 8. Okay. So I reach in, I get me a blue pen, and I keep it out. And then I go in, I reach for another blue pen. Well, how many total pens are in the box now? Pens. 7 total, right? And how many are blue now? 4. So the total went down by 1. And also, since I'm going for the same color, the blue pens went down by 1 also. Y'all see that? So if they're reaching for the same color or whatever, same type of thing, then that top number goes down as well. Does that make sense? Okay. Multiply those across. 5 times 4 is 20. 8 times 7 is, and I think they're both divisible by 4. Right? Your calculator should math enter that one. Does it?
Oh, yeah.
If I divide them both by 4, I get 5 out of 14. Like you said, your calculator should do that one. Okay, so now on my problem 2, I'm reaching in 3 times. I want to get a black, keep it out, get a black, keep it out, and get a blue. In that order, black, then blue. Keeping them out because it says do not replace them. That means you don't put them back in the box after you take them out. So what's the probability? Starting over, I still have 8 in the box. That's my first denominator. What's the probability that the first one I get's black? 3 over 8. Here each end, I get my black pen. My probability that I get a black pen on the first try is 3 out of 8. I keep my black pen out. So now how many total pens are in the box? 7. That went down 1. How many of them are black? 2, because I've already taken out 1 black one. Does that make sense why that number goes down? Okay, because I'm repeating black pens. Then I'm going to go back and get a blue pen. Well, now how many total pens are in my box? 6. The total still, as long as I'm not putting them back in, my total's still going down by 1. Does everybody understand that? And how many are blue? Have I used a blue one yet? No. So how many blue are in there? 5. Does that make sense?
Yeah.
And then I multiply across my top. That's going to be 30 over 56 times 6. My calculator's not doing anything. I'm going to do one like your calculator so that way I can see what yours is doing.
It's 336.
8 times 7. I believe you. I just want to have it 336. Now, I know this reduces, right? See if your calculator will do it. Math, enter. 30 divided by 336. Math, enter. What is it? 5 out of 56. Yeah. So any questions about the box of pens? We're good on those? So if we're drawing and not replacing, then the total goes down 1 every time. And if you're reaching for the same type of thing, those go down as well. The numerator will.
Richard Kennedy, come to the office. Richard Kennedy.
All right, back to our decks of cards. We've talked about them for a few days now. We got 52 in a deck, 4 different suits. There's 13 per suit. I guess that's it. What's the probability? Okay, it says we're drawing from a deck of cards. We do not replace them after we're drawing. Find the probabilities. How many total cards are in a deck of cards? 52. If you don't have that written somewhere in your notes, you might want to have that handy on your notes where you can see it. There's 52 total cards in a deck of cards. Not count the joker. Okay. So what's the probability that I draw a spade, keep it out, draw another spade, keep it out, and then draw a heart? Okay. So my total card is going to be 52 to start with before I draw anything. Right? What's the probability that the first one I pull out is a spade? How many spades are in a deck of cards? 13, a fourth of them, right? So 13. So the first one I draw is a spade. How many total cards are left? 51. We go down by 1 with the total every time if we do not replace them. How many of them are spades? 12, because I've already used 1 spade, so I'm going for another spade. So that's 12. Then what happens to my total? It goes down to 50. And then I want to draw a heart. Well, how many hearts are still in the stack? All 13 of them. And then we multiply those together. Is everybody okay with that? All right, so 13 times 12. I believe you. I'm just trying to get there. 13 times 13 times 12. 2028. And 52 times 51 times 50 is 132,600. Let's see if that'll math enter in. It will, won't it? What'd y'all get for that reduced fraction? 13 over 850. So when y'all making your quiz for tomorrow, I'm going to try to make sure that all your fractions will do math enter. Uh-huh. Did you do 13 times 12 times 13 and get 2028? Huh? Gotcha. All right. So now, the last one we want the probability of getting a jack, and then an ace, and then another jack. Okay, in that order. So, back to the whole deck of cards. How many total cards do we have? 52. How many jacks? There's 4 out of the total deck. Right? Times, then I want an ace. Well, how many total cards are in the deck now? 51. How many are aces? Still got all 4 of my aces. Right? And I keep those out. And then I go back, and how many total cards are in my deck? 50. And how many of them are jacks now? Yeah, I've already used 1 jack, so now I have 3 jacks. Does that make sense? So on top, I should have 48. And the denominator will be the same thing as the denominator was a while ago, because I'm multiplying the same 3 numbers. And then math enter that baby and see if it'll do it. It should. It might not.
Yeah.
It won't do that one. So we'll leave it like that. Oh, actually, we can maybe if we divide it a little bit. We know they're divisible by 2, don't we? So divide them both by 2.
It's 20 over.
24 over 66,300. See if that one will math enter in.
No.
Still won't. We can divide it by 2 again, can't we? Well, aren't you fancy? So this one, if I divide them both by 12, I get 2 out of 5,525, right? I'll try to math enter that one. It shouldn't. That won't reduce anymore, will it? I don't think so. It tells you the same thing back, don't it?
Yeah.
Good job. Okay. So yeah, sometimes we have to simplify by our brains. And we know if they're both even, we can at least divide them by 2. If they end in a 5 or a 0, they're both divisible by 5. If they're both in a 0, they're both divisible by 10. So sometimes we have to use our little math sense. So that is the end of probability for today. Have a good day.